question. Okay. Right. So after the exam one, we actually covered 4 chapters, right? 2 based on probabilities, another 2 based on distributions, right? So let's start with probability. Suppose we have 5, 6, 7, 8, 9, 10. Suppose there are 11 people, okay? And let's say 5 of them are male and 6 of them are female, right? And then let's say these 3 men are wearing red t-shirts. These 2 are wearing blue t-shirts. These 4 are wearing red. These 2 are wearing blue. Okay, so we have 11 people total, 5 men, 5 males and 6 females. And the color of the t-shirts, they will like this. Okay. Now suppose we are defining some events, right? So the first event, let's name it as A. Let it be choosing a male. And the event B is choosing a female, right? And event C is choosing someone with red t-shirt, and event D, someone with blue t-shirt. Okay, right. So, any questions so far? Right. Now, let's try to calculate some probabilities. Okay. Suppose I put all these 11 people to a room, right? And then let's calculate this. Okay. I will give you about 2 minutes to calculate those 4 probabilities. Now the time is 6:04. So let's spend about 2 minutes. Okay, so this is a very basic exercise. Now we have 11 people in total, and how many elements are there in the event one, right? So that is choosing male. We have 5 males, so the probability will be this one. Okay, always if they ask for a probability, it will be a number between 0 and 1, and if they ask for a percentage, then you just have to multiply it with 100%. Okay, right. So that's simply now if I calculate the value, it will be 0.45 something, or in terms of a percentage is 45%, right? So that means if you put all these 11 people into a row, and if I choose someone at random, there's a 45% chance of that person being a male. Okay, and the probability of B, that is choosing a female, is 6 by 11. And probability of choosing someone with a red t-shirt, that means you just have to count 1, 2, 3, 4, 5, 6, 7. There are 7 people with red t-shirts. And blue, we have 1, 2, 3, 4, right? Those are the probabilities. Any questions? Okay, now how about this? Okay, another 2 minutes. Calculate these probabilities. Now the time is 6:09. Spend about 2 minutes. This is and, this is O, and O, and O. Try to do it on your own. Don't discuss with friends because I'll be telling you the answer shortly. So try to do it on your own. You don't have to calculate the decimal values. I just need these fractions. Okay. But for the exam, it's okay to have the decimals. All right. So, what do we mean by A and C? Oh, in other words, what's the difference between A and C and this one? So, this is something you should clearly understand. Okay. When it comes to A and C, right? So, suppose these 11 people are in a room and you pick someone random. And for that person to have this quality, the quality being A and C, that means that person should belong to this set as well as this. What about this one? AOC. For that, it's enough for that person to belong into at least one set. Okay, so that's the difference. So if someone is a male, right? If you have a male, now let's take this guy. He's a male wearing a red shirt, right? So this person belongs to this set as well as this shirt. This one also the same, this one also the same. So this guy is a male, so belongs to this set, but wearing a blue shirt. So this person does not belong to this category. Okay? That means this fourth person is included in this set, but not in this set, right? To become an element of this set, where you connect two events with an AND, you need to have both properties satisfied at the same time. Is that clear? Right. So we just have to check how many people are there with this property. Property in the sense, being a male as well as wearing a red shirt. Okay. So how many are there? We have this one, 1, 2, 3. That's all, right? So it is 3 by 11. How about this one? So 3 by 11 means if you put everyone into a room and if you choose someone at random, this is 0.27 something. Or in other words, as a percentage, it's 27%. So if you put all these 11 people to a room and if you choose someone at random, there's a 27% chance of that person being a male and wearing a red shirt. Okay? Right. Next, AOC. So that means it is enough for that person to be an element of this set or this set. So it is enough to be an element of at least one set. Okay. So if you choose this one, belongs to A, so he falls to this category, right? AOC. This one male and also satisfies the other property as well. So this is okay, this is okay, this is okay. How about this one? Although he is wearing a blue shirt, that means he does not belong to this set. But since he is a male, he also should be categorized under this set. Is that clear? Right. So this one is included, this one is included. How about this one? She's a female. So not in this set. But since she is wearing a red shirt, belongs to this set. Therefore, also included in this set. Correct? Right. So we have this one because of this reason, right? And how about this one? A female. So do not belong to this set. wearing a blue shirt, so do not belong to this set. Then it's not included in this A or C category. Okay, so to exclude someone from this category, that person should not belong to A, should not belong to C. Okay, so there are only two people like that. The rest will be included. So we have 9 by 11. Okay. So basically, what's 9 by 11? That's 81. So 0.81. So there is an 81% chance for that person to be a male or wearing a red shirt if you pick someone at random. Is that clear? Right. How about this one? It's very similar. B and C. So B means being a female. C means wearing a red shirt. So, and means both should be satisfied at the same time. Therefore, we have to look for females wearing red shirts, right? Now we have 1, 2, 3, 4. There are 4 out of 11. Okay. B or C, either a female or wearing a red shirt. So this one, although this one does not belong to this set, he belongs to this set, right? So that person must be included in B or C category, right? So this one is included because of the red shirt. This one because of the red shirts. This one, a male, so that doesn't belong to this set. Wearing a blue shirt, that means also does not belong to this set. So this one is rejected from that category. Any questions? So this is rejected, this is rejected. Everyone else is there because this one, since she's a female in this set, at once included in the set. So, and finally these two, although wearing a blue shirt, since they are females, they should also be included. Okay, so only 2 people are removed from the 11 total, so you have 9 by 11. Any questions? All right. How about this one? Any suggestions? So you just have to read it correctly. Okay. We have 2 sets combined with and. That means both properties should be satisfied, right? So A is being a male, B is being a female, but in these 11 people, none of those are included in both sets, right? So it will be either a male or a female. So none of these 11 people have both properties at the same time. Okay, so we have 0 such people out of 11. Therefore, the probability is 0. That means if you put these 11 people into a room, pick someone at random, there is 0 chance for that person to be a male as well as a female. Right? How about this one? Any suggestion? Very good. 11 out of 11. Right? So that means here it says either A or B. So it is enough to be an element of at least one of the 2 sets. Right? So if you take these 11 people, all these 11 people can be included either in A or B. Right? So when you take A or B, it speaks about the entire population that we are considering here, right? So we have 11 options out of 11, and that is 1. or it is 100%. When you multiply this by 100%, it is 100%. Okay, that means there's a 100% chance for that person to be a male or a female. Right? Any questions? Yes.
Shouldn't we be taking probability of 8 and time it by probability of C?
Right. So you mean for this one? Okay, I will come to that point later. Okay. But to do that, you need some properties to satisfy. Okay. We will discuss it later, but it's a good point. Okay. Right. Because just because you have these sets, you cannot multiply the probabilities like that. Okay. Right. Right. Now, how about these two? Another 2 minutes. Time is 6:23. Right. So, what before going into that, I will answer her question. The thing is, if I project the screen, it is not clear. So, I have to move the screen. Otherwise, if I just project it to the board, things are not clear. So, now see, this is the multiplication rule that we have. Okay. It says two events A and B are independent if knowing that one occurs does not change the probability that the other occurs. So if that is true, we can say that the probability of A and B is PA times PB, right? But the problem we have here is if we know that this thing happens, so suppose you choose someone And if that person is a male, right, that kind of prevents that same person being a female, right? So it has some effect on this set. So in such cases, the sets are not independent. Therefore, you cannot apply the multiplication rule. Okay, so always this multiplication can be done when you have independent events, right? That's something important. Right, so I was talking about this thing. Now there are a couple of things related to this. You say that, like, the way this is defined is probability of happening A when C is given. Okay. Now we do have some formulas. Actually, a formula. If probability of X given Y is equal to probability of X and probability of Y divided by probability of Y. Okay, so we do have a formula to do that, but without even using any of these formula, we can calculate the probabilities just by looking at the domain. Okay, for that we have to correctly understand what A given C means. Okay. So what do they mean by the probability of A given C? Now suppose we have all these 11 people in a room. Okay. Now you need to find the probability of A. That means probability of choosing a male when C is given. What do they mean by C is given? So what happens is, out of these 11 people, suppose you separate out everyone in this set. That means this one, this one, this one, this one, this one, this one, this one. Right? So you have one. Erase this. Now you have to separate everyone who is wearing a red shirt. So this one, this one, this. Now I am going to separate them from the main group. Not this person, because he is not wearing a red shirt. And these 4 females. Right? So we have 7 all together. Right? So if we separate out those 7 people from the main group, 3 will be male, 4 will be female. Okay, so we use this condition to separate the smaller set. And from this set, what is the probability of having a male? That's 3 out of 7. Okay, you don't need any of those formulas to calculate conditional probability when you have a sample space like this. Okay, now I am doing this example just to give you a kind of an idea about these notations and everything. Okay. Also, if you use the formula, you will get the same thing. Multiply. You have to divide this by this, right? So that's probability of A and C divided by the probability of C. Probability of A and C is 3 by 11. and you have to divide it by 7 by 11. Since this is division, you have to get the reciprocal and multiply. You have 3 by 7. Okay, so even with the formula, you can do the same thing. But try to understand what we are doing here. Okay, so we separate out this condition and evaluate the probability in that separated portion. Okay, how about this? You want me to calculate it in this way? Now the time is 6:32. Okay, so here they ask about the probability of happening C when A is given. A is given means we have to separate out everyone with respect to the condition A. So A means choosing a male. Separate out these 5 people. Out of those 5 people, what is the chance of them wearing a red shirt? 3 by 5. Okay. Right. One more question related to the doubt that she asked. Now, so why didn't we write A and B as PA times PB? Now, so the basic idea is you need those sets to be independent, right? Now, independent means having one, like satisfying one set should not have any impact on the probability on the other, right? So, if knowing that one occurs does not change the probability that the other occurs, okay? So, the thing is, now, if this have not, what about A and C? Why can't we do that for A and C? Why can't we have P A times C for that? It won't be true, right? 5 by 11 multiplied by 7 by 11 is not equal to that number. Okay? Now, the thing is, suppose you have A, right? So, suppose you choose someone who is a male, right? Then the thing is, you have, like, you are kind of reducing the number of elements in the sample space, right? So, if this occurs, and then if you are looking for the probability of happening C, then if this person is already removed from the main set, you have only 10 candidates. So all these values will change after that. right? So, but say if you are tossing a coin 2 times, right? You toss the coin once and you toss the coin for the second time. So that doesn't have any influence on the first toss, right? So things like that are known as independent events. And if you are kind of changing the number of elements in the sample or the population, they are not. They depend on each other, right? And this is also a good way to check whether elements are sets are independent. Sometimes they can give you questions to calculate the probabilities using the basic principles and see whether it satisfies this equation. And if they don't satisfy the equation, you can safely say that they are independent. Okay, so it's another way that you can use this equation, right? Okay, any questions? So you have to know the idea of this conditional probability very correctly. Okay, right. Any questions at all? Right. And next, we did something about two-way tables. Okay. Now, when it comes to a two-way table, let me take kind of a similar example that we did in the book. Now, suppose in a forest, you have three types called A, B, and C. Okay, so these are some names of different trees. Okay, and suppose there are different states for these trees. One is dead, the other one is live, and the third is sapling. Sapling means a very young tree. Okay, so live and saplings are both alive, but they are kind of separated into two different parts depending on their age. Okay, right. So now when it comes to a two-way table, it can be given in couple of different ways, basically two. Okay, so they can either write a number here or they can write the probabilities. So you have to understand it carefully. Now I think in your lab assignment they have given you numbers, and in the examples in the book they have probabilities. So you should not get confused with the two-way tables just because the way they represent it. Okay, so now the story behind this table is you have a forest and there are three different types of trees, A, B, and C, named as A, B, and C, and there are three different states for those trees named dead, live, and saplings. Okay, right. So now suppose in this forest you find 100 dead trees of type A, 50 alive, and 20 saplings. Okay, and let's say this is 200, 100, and then 50, and this is, let's say, 10, 20, and 30. Okay, just put in some random numbers which can be easily added. So Now, you should know how to read these final columns and rows correctly. Okay. Now, what does this this segment represent? This number here that will appear here should give you the total of dead plants. Okay, that is 100, 200, that's 310 dead plants. That's all. Okay. Here it should give the total live plants, 151, 70. And this one should give you the total subplace. So that is 70 and 100. Okay. And this part should give you the total number of type A trees. Right? So that's 150, 170. This should give you the total number of type B trees and type C trees. Right? And this value will be the total number of trees. Okay, so these two values should match. Right? Set them up. 170, 350, and 65, 80. So you can see, even if you add this way or this way, both values must be the same. Okay. Right. So this is one interpretation of the two-way table. Okay. But what if they give you the probabilities? Okay. Without going into probabilities, you should know some more. Now, this point, what is the property of a tree belonging to this part or this segment? That tree should be of type A and it should be dead. Right? So it basically speaks about this thing, the combination with and. Okay, so all these positions will give you some idea about satisfying whatever the relevant property with respect to the row and the column. Okay, so in a two-way table, you have the combinations through and for the given two properties that are represented in the row and the column. Is that clear? Right. Now, if it comes to a probability, how do you find the probabilities? Now, this is the total number of trees, right? In the forest, you have 580 trees. Now, what is the probability of finding a tree of type A and that tree being dead? Since we have the numbers, we can write this number divided by this number. And so this is the total number of trees with this property, right? And this is the total number of trees in the entire forest. It's very much similar to this category, this representation. The total number of people satisfying these two properties along with and is only 3. And there are 11 in total. And in here, you have 100 divided by 580. Okay, so that will be.
I have a question.
Yes.
Why didn't we say it's 100 over 310? Why did we Pick the whole total for the whole cheese.
Okay. Good question. I will come to that. Okay. So that's 0.07. No, 0.17. Okay. I will answer your question. Okay. Now, here, this number 100 represent all trees which are dead and of type A. Correct? Now here, this number 3 represented all people who are male and wearing a red t-shirt, right? What is this number?
Total for the dead trees.
The total dead trees, correct? So, what is this length? Probability of finding type A given the trees are dead. What's the meaning of that? If we separate out all the dead trees in the forest, from that thing, what is the probability of finding a tree of type A? Right? So, to do that, first of all, you have to separate out all the dead trees in the forest. So, how many trees that I might find? 310. So, here you have 310, and out of these 310, how many type A trees you will find? 100. So, this one will be 100 divided by 310. Okay, so you can even use the formula. Probability of A by D given D is equal to probability of A and D divided by PD. Right? Now, okay, let's calculate PD. What is PD? Probability of finding a dead tree in this forest.
310 over 100.
Very good. So, if we think about this entire forest, what is the probability of finding a dead tree? There are 580 total trees. Out of those 580, we have 310 dead trees. Right? Now, if we substitute it to this equation, we have 100 divided by 580 divided by 310 divided by 580, and that will be equal to 100. 580 multiplied by 580 divided by 310. Right? So, you have to have a very clear idea about conditional probability. Okay? And something that you should kind of understand is, in the two-way table, these values represent the things with respect to and you have to manually calculate conditional probabilities. But when it comes to a tree diagram, the conditional probabilities are given, you have to calculate the and part. Okay, so that's the main difference between the two. Okay, right. One more thing. Now here, we kind of manually calculated these values, right? So this is 0.17, and if you need, you can even calculate 3 310 divided by 580, that's 0.53. Right? So you can calculate these values like that. But sometimes in the two-way table, instead of giving these numbers, they will give you the probabilities, the direct probabilities. Okay? So in that case, what you will have is a table with the probabilities 0.17, 0.53. Likewise, we will have all the probabilities. Okay? And if they ask you to calculate this one, what you need is probability of A and B divided by the probability of D. Now, A and D is directly given. You don't have to do anything else. Right? So we have 0.17 divided by PD. That's also given at once. So you can directly use this number. Right? So depending on the way they give you the two-way table, you have to handle that. Okay? Any questions? Right. Next is the tree diagram. Now I think, yeah, you are allowed to have a sheet of notes. So have these important formula in your note sheet. And yeah. Now, when it comes to a tree diagram, representation is slightly different. We can use the same thing. Now, there we have two categories, either a male or a female. Okay, so this is being a male, this is being a female. And for a female, for a male, you have two options: wearing a red t-shirt and wearing a blue t-shirt. Yeah, blue and red. And this one, for a female also, she has two options, blue and red. Now, what do these like? Now, how do we assign the probabilities across these branches? What is the probability of being a male? That's this part. That is 5 by 11. And the rest goes to the other column, 6 by 11. If you have 3 options, you will have to correctly distribute the probabilities. Now, this part is not tricky, but you have to be careful. Okay. So this says that it is a blue t-shirt wearing person, but also a male. So we know that it is a male, and you need to calculate the probability of him wearing a blue t-shirt. Now, if you come to this point, we know that it is a female. What is the probability of this female wearing a blue t-shirt? In other words, this is the probability of someone wearing a blue t-shirt given that it is a male. Okay, so now wearing blue, I represented with the letter D and this with letter C. Okay. So whatever the number you write here, now being a male is A and this is B with respect to those definitions. So whatever the number you write in this branch will be the probability of happening this when you have this. It's not D and A, it's D given A. Okay. Right. And we calculate by using these two values. Now this is the probability of A. Okay. By using those two values, we do another calculation for a tree diagram. That is, now we already know that we have this relationship B and A divided by PA. So if you multiply this throughout, it will be equal to P, D and okay. So if you multiply these numbers together, what the result you get is P, A and okay. And if you multiply this one and this one, the result you get will be P, A and C. Right? So now see the difference? In the tool table, these columns represented the AND value and you had to separately calculate the conditional probability. But in the tree diagram, the values you have are the conditional probability, and by using these values, you have to calculate the AND term. Right? So now that's the main difference, and you should know how to deal with this correctly. Right? One more thing. Now, this kind of a common question that they ask when it comes to tree diagrams. Now, suppose you need to calculate the probability of people wearing a red t-shirt. So, someone wearing a red t-shirt means it can be a male and a red t-shirt or female and a red t-shirt. Okay, so probability of someone wearing a red t-shirt, that's represented by the set C, should be this one or this one, right? Now the rule of thumb is, if you are thinking about two separate endpoints, just add them up. Like basically, if you are going across these branches, you multiply. And if you think about separate branches, you have to add them up. Okay, so you need to have this one, that's males wearing red t-shirts, as well as females wearing red t-shirts. So multiply these two probabilities, you have probability of A and C, add it to the probability of B and C. You will get the same answer. Okay, so especially if they ask for a value in these regions, and if the same value is repeated more than once, go through the branches as well as make sure to add them up. Any questions? But don't just remember those things blindly. Just try to understand the concept. Any questions? Okay, now I have to highlight this one, like these are not the only things you need for the exam. Make sure to read the book and especially do the homework questions and also write down the important formulas. Okay, right, so that's it for probability. And then we did something about distribution. Okay, okay. Now for distributions, we discussed about normal distributions and binomial distributions. Okay. Now, when it comes to a normal distributions, it has a long story with respect to density curves and all. I'm not going to talk about density curves here. But simply, a normal distribution is something like this. Okay. And to calculate the probabilities, you need to calculate the area under this curve. That's the most basic task you should do. Now, when it comes to a normal distribution, always center is the mean. Okay. And you have a standard deviation. And with respect to the standard deviation, we have a thing called 68, 95, 99.7 rule. That's something you should know. Okay, because it's very helpful to evaluate areas even without using crunching, right? And even if you use crunching, you should know two things. One is, now the first thing you should understand is when it comes to normal distributions, you will never get, like, they will never ask you a question like this. Calculate the probability of x being equal to 3. Okay, so always, if it is a normal distribution, you will be given with the range, right? Because if the sample space is continuous, the probability of a single point doesn't make any sense. It's basically 0, right? So, one thing you should know is, if they give you a point here, right? Basically, if they give you a range like this, now let's say if this is 2.5, if they ask you to calculate the probability when it is greater than 3, you should know how to calculate this area. Okay. And if they give you something like, let's say, x less than or equal to 2, even if they give you as greater than 3 or greater than or equal to 3, that doesn't make any difference. Okay, so because the reason is, the only difference here is they have included 3 here, but just a single number in a continuous sample space doesn't do much of a difference. Okay, right. So now when you have something like this, it's 2 somewhere here, you should know how to use crunch it and evaluate this area, right? And also you should know how to calculate areas in a given interval like this. So that will cover this part. Okay, because in Crunchit you cannot input an interval like this, right? So you have to separately cover them. Okay, so if you are having some struggles with calculating these stuff, please watch the videos and do the exercises in the book. And you can even email me if you have any kind of quick question, if you need any quick clarifications. Okay, right. So that's about when you have this value and calculating the area. And the area represents the probability. Okay. And you should know how to do the reverse direction as well. If they give you the probability, let's say this is 10%, how do you calculate this value? Right? And that is sometimes tricky. Okay, because now, say if we have a normal distribution, and if they ask you to calculate the first 10%, that's up to this point. Okay. And in Crunchit, this goes with the thing called quantize, right? And so you just have to input 0.1 in the quantize section, and they will give you the, if this is 10%, they will give you this x-axis value. But the thing is, if they ask you about the last 10%, right? In Crunchit, it always, now to find this coordinate, you need to use the thing called quantize in Crunchit, but it always talk about the area from left hand side. So if you just give 10% under quantize in Crunchit, it calculates this area, right? So there is no way to input the largest 10% directly in Crunchit. Okay, but what you can do is, if this is the 10%, to the left, it will cover 90%. Right? So that means we have a graph. Now, our main goal is to find this point, right? So we have a graph where it covers 90% at this point. Now input 0.9 in quantize and it will give you the answer. Okay, so always be careful when they have when they give you the percentage or the probability and when you are computing this x value. Okay, because sometimes it may not be direct, you just have to do the conversion. Right? And one other thing, we have 10 more minutes. So another thing you should remember is these normal curves are very symmetrical, right? So if we know that this thing covers, let's say, 60%, we have 40% remaining. Okay? And this 40% will be equally distributed in these two regions because it's symmetric. Okay, so don't forget the symmetric property of a normal distribution. It's important. Okay. Right. Now, what is binomial? Okay, one last thing. About normal distribution, I think a lot of you have problems with the standardized value. Okay. So standardized value is something like this. Like, let's say if there is someone who knows English, and if there is someone who knows French. So if this person says good morning, this person cannot directly understand it, right? So there should be some sort of a conversion so that this one can understand. So, and then again, if this one says thank you, it should be converted so that this one understands. Okay. The normal curve and the standard normal curve are something like that. So this is the normal curve where you have the mean mu and the standard deviation sigma. Standard normal curve. So the only difference is the word standard. This is the standard normal curve. This is just the normal curve, right? For the standard normal curve, it is also a normal curve with mean mu and standard deviation 1. So what we do is this sort of a conversion. Okay. So these are like two different universes. And if you have a value here, it must be converted to a value in here. Right? And the conversion will be done through a formula like this. If I remember correctly, this is the formula. Just double check that one. Okay. So, for example, if you have a normal curve with mean 10 and standard deviation 2, right? Standard deviation can be any value. It need not to be less than 1. Okay. So if the standard deviation is 2 and mean is 10, and if you have a value like, let's say, 1000, so that's a value in this world. Okay, so 1000 is here, and it must be converted so that people in this world can understand. How does the conversion work? So this Z represents the normal value, the standard normal value. So just put 1000 here, and the corresponding mu is 10, and the standard deviation. So whatever the number you get here is the corresponding number in this world to this number. So if you convert good morning to French, that will be a certain term, right? So that conversion will be done through this formula. Okay. Right. Any questions?
It's hard to read.
Oh, sorry. So it's like we have 1000 here, and it will be x minus 7. Thousand minus mu is 10, and the standard deviation is 2. So this will be 990 divided by 2. And this number is the corresponding number in standard normal curve. The standardized value, or the Z value of 1000. Okay. I'm not 100% sure about this formula, just to double check that one. Right. Any questions? Okay. And finally, we did binomial distributions. Now, in a binomial distribution, the key point is that you have a thing called a success and a failure. And then they define a parameter called the probability of success. Now, we did a lot of examples related to the probability of having a blood type O, right? That's 0.45, okay? And then, suppose you have, let's say, 5 people, no, let's say 10 people in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 people in a row. Okay. Now, if this is the national average, that's 45% have the blood type O. If there are 10 people in here, and if you directly incorporate this probability value, 45% out of 10 must have the blood type O, right? Because this says the national average is 45% to have blood type O. So if you have 10 people in a row, if you directly incorporate this value, you should have this many people. That's 4.5 people. Let's take 5. We should have 4.5, or let's approximate it to 5. So there should be like 5 people in this row with the blood type O. Is that clear? But the problem is sometimes this entire row can have 9 people with blood type O. That's also a possibility, right? Sometimes it can have 7 people with blood type O. Sometimes it can have 4. Sometimes it can have 0. Like none of these people may be having blood type O. Right? So although this calculation can be directly done, it's not a 100% guaranteed answer. Right? But the thing is, since this is the national average, it's somewhat unlikely to have 0 people with the blood type O. Now, for example, if this is the national average and if that is accurate, we have about 20 people in this room. And if I say there are 0 people with blood type O, it's somewhat unlikely, right? And if I say the probability of the number of people having a blood type O is greater than or equal to 2, that can happen, right? So these are called binomial distributions, and you can directly calculate this through crunching. Okay, so you have to know that as well about calculating these binomial distributions. It's a direct thing. You just have to input the numbers. Okay, so please practice these problems again and again. Redo all the homework questions as well as the lab assignments. Then the exam won't be that difficult. Okay, so practice hard for the exam, and I'll meet you guys on next Tuesday. Before you leave though, I need to quickly take your attendance.